Hey, how you doing? Quick little lesson on reaction profiles and mechanisms. You've seen this before. We're just going to apply it slightly differently. All right. So let's go ahead and do that. Um, and let me share my screen. Come on, perfect. It's coming. There we go. All right. So reaction profiles and mechanisms. Remember, mechanisms are multiple steps showing how we actually get from reactants to products. Step 1, step 2, step 3, or 4 or 5. There's always a slow step. We said that the slow step is the rate determining step. The slow step would have the highest activation energy. It would have the highest barrier to overcome, okay? So here's a graph. Here's, first of all, a generic mechanism, okay, with our step 1 and our step 2. We know the first step is slow and the second step is fast. And I have already drawn a reaction profile. So let's just look at it a little bit more closely. Over here, we've got the potential energy. You might want to pause and draw your profile. Down here, we have the reaction coordinate. All right. It is also true that at the beginning, we have the reactants. We have seen that before. The only difference here is we have two or more than one hump or activation energy. And we still have the products down here. All right. What we see in the valley in between activation energy barriers, right? This is an activation energy. This is an activation energy. They are barriers that must be overcome. What we see in the valley here would be our intermediates. All right. And up here, we would have our activated complex for step number 1. And here we would have our activated complex for step number 2. Okay. Notice that we are told that the first step is slow and exothermic. So my first step has the highest activation energy. Okay. The slow step has the highest activation energy. It's got the highest barrier to overcome, thus it takes the longest. There are less molecules that have the required energy to activate. The higher the activation energy, the less molecules you have, okay? Also notice that we were told that the first step is exothermic, and we see that represented in our graph because here's the energy of the reactants in the first step, and the energy of the products in the first step is less. So we see that energy has been lost, which is an exothermic reaction. And then we see step 2, which is the fast step, has the lower activation energy, and its initial energy is here, and the final energy is here. So we see that once again, the products have less energy than the reactants. So in both of our exothermic, we see that products have less energy than reactants. Potential energy than reactants, okay? All right, let's go ahead and just look at another example. That's the same thing. All right, let's do this one. We've got 2 steps again. So let's draw our lines. Let's label our axis. Okay, it's kind of messy. Okay, so we have a slow step that is endothermic is first. So let's start here. Let's give it a high activation energy, and let's have the products have a greater amount of energy than the reactants. And then we have a fast step, so we have a lower activation energy, and it is exothermic, so the products have a less energy than the reactants. Okay, let's label this. All right, I'm gonna get my red. These are my reactants. These are my products, right? This is step 1, this is step 2. Step 1 has the highest EACT, and endothermic means products have more energy than reactants. Okay, and you see that right here, right? Here's the first step is endothermic. Here's the reactants energy, and here's the products energy of the first step, right? The intermediate here is the product of the first step. All right, and then in the second step, right, there's your endothermic where we gained energy. And then in the second step, it's exothermic. So we see that the reactants in the second step have more energy than the products in the second step. So energy has been lost, right? E lost. Products have less. Okay, hopefully that makes sense to you. Let's do another one since it's here. You can pause. See, we got a slow step. So the first step is slow. It's exo. Oh, I better start higher. It's exo. So the line has to come below it. Second step is fast. So a lower activation energy, exo, comes below it. Third step is fast. Lower activation energy comes below it. Reactants, products, step 1, step 2, step 3. We know that this is the slow step because it has the highest activation energy. All right, last one, and we're done here. What can we infer from looking at this graph? Well, we can infer that there are 1, 2, 3, 4, 5 steps to this mechanism. Right, we can infer that. Is that in the way? We can infer that the second step is the slow step. Right? We could infer what about the overall enthalpy of the reaction? Delta H reaction is exothermic, right? Because the products have less energy than the reactants. We can say that step 1 is, let's see, if we start here and we end here, is that X over endo? Is endo. We could say that step 2, you figure it out. We start here, we end here. That's XO. We could say that step 3, here to here, is once again XO. Step 4 would be endo. And step 5, overall, or not overall, but step 5 itself is exo. Okay? So that, my friends, is the reaction coordinate energy profile for multiple step reactions. All right? Have a great holiday.